P, P, B. This would be our string. Okay. Twice n number of A's, twice n number of B's. Basically, what we are saying, thrice number of times 2 multiplied by 3 is 6 number of times B and 4 number of times A. What we will do, for first A will do nothing. For second A will push X on the stack top. Again, third A will not do anything. For fourth A will push another X on the stack top. Basically, for each 2 A's, we are pushing 1X. Okay. And now when we are going for reverse, what we will do is, for each 3 B's, will pop 1X. So first B, keep X as it is. Second B, keep X as it is. Third B, pop 1X. Similarly, 1, 2, skip. Third B, pop X. And as soon as we get epsilon here, at that time we must have Z0 on the stack top. If it is the case, in that case, go to final state. But the condition, one more condition available here is n is greater than or equal to 0. It means we may have n equals to 0 also. In that case, our string would be directly epsilon. So this is the second case which we need to take care of. So first case would be n greater than 0. For that we'll construct PDA. And thereafter, for the second case, that is n equals to 0, we'll modify our constructed PDA to accommodate this criteria or this condition. So let's go for construction of PDA for this. But we are saying that initially we are assuming that n is greater than 0. So we need to go on pushing X, 1X for each 2 A's. That process will follow. Let's go for Q0. First A on the stack top, naturally initially we have Z0. We are keeping Z0 as it is. For each second A, we are pushing 1X. For second A, on the stack top, it is but natural. Initially we'll have Z0 only. We'll push X on the Z0. Now again, third A need to be skipped, and for fourth A, push another X. So what we can do here is, let's go back to this scene again. A, but this time that stack top would be X. Keep X as it is. And for the next A available and stack top as X, push X on X. So this process will continue, right? And if we have even number of A's, in that case, this process will end in Q2 on the receipt of B. When we received B, we need to check, do we have 3 B's available? So first B, stack top as X, leave X as it is. Second B, stack top as X, leave X as it is. On the receipt of third B, since we are looking for thrice n, on the receipt of third B, will pop 1X. So let's represent that scene here. B, X, since this is the first B, keep it as it is. Q3. Second B, again, keep X as it is. And when we get third B, at that time, for that third B, we need to push one, we need to pop 1X from the stack. Okay. Now this process will continue. Q4 followed by Q5. This process will continue till all B's have been either skipped or have been compensated for 1X from the stack. Okay. So this process to be continued means what? First X, first B, second B, third B. Again, the next B coming would be the first B among the series of next three Bs. First B, second B, and third B. This process we need to do. So let's move to this place. First B on X, keep X as it is. Second B, skip. For third B, replace X with epsilon. That means pop X. This process of three consecutive B's checking will continue till all X from the stack like this have been popped. So this process will end when we have popped the last X from B. That means here. At that time, in input, we will have epsilon, and on stack top, we'll have Z0. So Z0 kept as it is, and we went to final state. So this is the case for n greater than 0. First case we resolved. That means when A's and B's are available and value of n is greater than 0. What if n is equals to 0? We have seen this case n equals to 0 means your string itself is an epsilon that we will encounter in Q0 itself, wherein stack top is Z0. So epsilon Z0, keep Z0 as it is. Okay. And since Z0 means string, input string is not available, you can directly move to final state. This is your case number 2, that is n equals to 0. Case 2, case 5. This is what we discussed about. Okay. Now, if you see here, example A states about construct PDA for L such that its acceptance by final state we need to show, and again acceptance by empty stack also need to be shown. Here what we discussed is about acceptance by final state. That means if the input string getting accepted, we are moving to final state. So what would be acceptance by empty stack? Acceptance by empty stack simply means that when you want to indicate that your given input is accepted, you must pop bottom of stack indicator also. So your stack would become empty. It will not have even the bottom of stack indicator. That's all. Your stack should be empty. If your stack is empty at the end of input string, when you have not specified any transitions as such, stack is empty. That means you are assuming that your input is accepted. But if stack is not empty, it contains either any symbol or Z0. It means the given input is not accepted. So the case which you have shown here on the diagram on the screen, basically this is the transition diagram for acceptance by final state. I'll modify this diagram for acceptance by empty stack. What does it mean? When we say acceptance by empty stack, that means we no longer need final state. So double circle state is not required. So this diagram now doesn't contain any final state as such. Apart from this, we need to ensure that our stack is empty. Now stack is empty means what? We will not have Z0 also on the stack. Instead of this Z0, we'll show epsilon. Similarly, this Z0 also, instead of that, we will have epsilon. Now, this is another Python automata wherein we are representing acceptance by empty stack. Is this clear to you? The difference between acceptance by final state and acceptance by empty stack?
Yes, sir.
Great.
Yes, sir. Sir, in the example, we have questions specified that we have to show acceptance by final state or empty stack.
Yes, it will be definitely given. But I believe we should not think from the perspective of examination. We should think from the perspective of how the logic, how things works, right? How automata works. And
Yes, sir.
you can write anything in the examination. So your learning should not be from the perspective of how to crack examination. Rather, it should be from the perspective of understanding the fundamentals. right?
Yes, sir.
So let's go for the second case.
Mm-hmm.
L equals to a raised to power I, b raised to power j, c raised to power k, such that I, comma j, comma k greater than or equal to 0 and I plus j equals to k. That means the number of c's is equals to the addition of the number of a's and number of b's. That's the meaning of this condition. And furthermore, your n, your I, j and k, all these could be equals to 0 also. So let's consider a I, b, j, c, k. If n equals to 0, what will be the string? If n equals to 0, that means I, j and k, all these three are 0, your string would be epsilon. If your I, comma j, comma k equals to 0, string would be epsilon. If I equals to 0, j equals to 1, your k would also equals to 1 because k is equals to I plus j. Your string in this case would become what? I equals to 0, that means a is not available. You have string as a b and c. Similarly, if j equals to 0, I equals to 1, your k will also become 1. Your I equals to 1, j equals to 0 and k equals to 1. Your string would become AC. In case of I equals to 1, j equals to 1 and k would become 1 plus 1 equals to 2. Your string would be A, B, C, C. Okay, so these are the different cases which we need to take care while constructing push-down automata for this. I already taken in this video that what is the difference between final state acceptance and acceptance by empty stack. So I'll be constructing the PDA for this acceptance by final state only. You can very well map it to acceptance by empty stack further. Let's go for it. Starting with Q0. What would be the first symbol? If you're assuming that I, J, and K all are non-zero values, ultimately you will have A as a first symbol. Okay. If we have A as a first symbol, let's push capital A for each A. Okay. So initially we'll have Z0 on the stack top. Push A for Z0. Q1 here. For all the remaining A's, those will come on this. We'll push A on A. This process will continue till we get B, which is the next symbol. Okay. Here, initially, we're assuming that all I, J, and K are non-zero values. So we are considering all the symbols A followed by B followed by C. So when we get B, and we have already had A, we will have capital A on stack top. Let's push B on A for that. For first B. Now for the remaining B's, we will have B on capital B. That is B on capital B, right? For the small b, we push capital B on the stack. This process will continue and it will continue till we don't get C, which is the third symbol. So on the receipt of C, what is to be done? We already ensured here that A's are followed by B's. So we do not have to check while popping whether A's and B's were in the sequence or not. That has been already ensured through the states Q0, Q1 and Q2. So what is left to be done here is just removal of the stack symbols for each C. C on the top of B we will get, right? Small c. Just pop this B. Q3. Here, what we will have? Any remaining B's. Pop all those B's, followed by C on A, pop all A's, and this process will end when we have all C's over and we got epsilon in input and Z0 at the stack top. If we have exactly the number of C's is equals to number of A's and number of B's. In that case only we'll get this situation. So go to final state. So this is the one case wherein we are assuming I, J and K all three as a non-zero values. Now we'll go for these alternative cases wherein I is 0 or J is 0. Okay. When I is 0, the situation would be like that the number of C's is equals to number of B's. So ultimately we will have B, B, C, C, this type of scenario, or B, 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 C, 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 and so on. Because A's are not available, we're assuming A equals to 0. So your first input symbol would be small b. Okay. So for this small b, what we will do is we'll directly go to the case wherein we are pushing capital B for each small b. That is nothing but the state number 2, Q2. From Q0 on the input of B, if we get directly B in that case, B Z0, because stacked up would contain Z0 as a bottom of stack indicator. B Z0, push B on Z0. And thereafter for all the B's, we'll have this B available on the stack top. So we'll go for Q2 BB gives B on the top of B. So this whole diagram will work for the same thing, same scenario. So another case we have solved wherein I is equals to 0. Now the third case, when I has some value that is non-zero and J is equals to 0, this is nothing but the scene like this. A, C, A, C, C, A, C, 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 and so on. That means we have same number of A's that of C, and we do not have B available there. Okay. Diagram will work in the similar fashion that for first A, we will have Z0 on the stack top. So A pushed on Z0. We'll continue with this A comma A gives A comma A. But here in between A and C's, we will not have any B because J is equals to 0. That is what we are assuming here. Okay. So that means what? In Q1, we will never get a scene like this B comma A because B is not available. After A's, we will have directly C's. So from here, directly we'll switch over to this C on A. C on A. Okay. Epsilon. And then for all C on A, we'll go with this rule. Ultimately ending with epsilon comma Z0 gives Z0. So this is this case. 1, 2. We have gone for all non-zero values also already checked. Last but not least available is all are 0. That is this case, which is nothing but seen in the way when we are on the stack top Z0 and in input we have epsilon. That means neither A we are getting in the input nor B we are getting in the input. So ultimately that scene is like this, wherein we are directly going from Q0 to QF. Epsilon comma Z0 gives Z0. So this is the transition diagram for case number B. Any questions on this?
No, sir.
Great. We're going to convert this into the case accepted by empty stack. What changes would be required to made here? It will not have final state, that for sure, right? We'll remove this. Similarly,
Yes, sir. And in the two stages with epsilon, we will replace
yeah,
Z0 with epsilon.
we'll simply do this.
Hmm.
Epsilon, epsilon. Okay, so this is acceptance by empty stack. If you have any queries, please let me know. Should I proceed for the case 3, that is